My name is Imam Ram, your regular tutor. We are still in the series of our lectures on mathematics. In this package, we are going to look at circle, and then I will ask you to bring your book and your Bible closer to you so that you can jot down the points that we are going to make. But before we start, let's look at the format of the teaching. The subject is mathematics, and the topic we are going to look at circle, behavioral objectives. At the end of this teaching, the students should be able to derive the equation of a cycle. They should be able to know the radius of a cycle. The students should also be able to know the general equation of a cycle, and they should know the length of tangents of a cycle, and they should know how to derive the coordinate of the center of a cycle if they are given the equation of a cycle. These are the objectives. Now let's take the definition of a cycle. A locus of a point in which the distance from a fixed point called the center is constant is known as a circle. The constant distance is called the radius of the circle. Now, a locus of a point in which the distance from a fixed point called the center is constant. So, such locus of a point is known as a circle. The constant distance is called the radius of the circle. Now, let's look at what we are trying to say. This is the locus of the point. Then we have that there is a fixed point here, such that the distance from any point on the center to here is equal to this distance. The distance from here to here is equal to this distance. So this distance is what we call the radius that is represented by r. Alright. Now let's find out equation of a cycle. Equation of a cycle. We are going to use the Cartesian coordinate to explain this equation of the cycle. We know that this is the origin. Now let's place a circle in the plane. Let's place a circle in the plane. Let's think make it small so that there will be space to explain some things. Now this is the center, as we know, and then this is the radius r. And so there is a point here in which we describe that at this point to this point is called radius. Now let these points be P, variable points have xy, and let this center here be A with coordinates AB at the center. So it means if I join these points with this one, I have a right angle triangle. So I will call this particular point B. Now what do we observe? We observe that if we trace this line to here, the coordinates at this particular point is x, and that at this point too, we trace it to this side, we have y. We also see that at this particular point, if we trace to this way, we will have b as the coordinate, and here tracing to here, we have a corresponds with a. So what it means is that AB, the distance AB from here to here, will be equal to x minus a. Of course, x minus a will give us this. So AB is equal to x minus a. And PB, this is P. PB is the same as this. This is y. In this place, here to here is the same thing as here to here. So we can get that as y minus b. Now, this is r, which is the radius. So, AP is equal to r. But we know that by Pythagorean theorem, we know that this right angle triangle, that r square is equal to, or let's say AP square, which is the distance of this to this, AP square is equal to AB square plus PB square. By Pythagoras, we know that very well. And so, but AP square, AB is R, so we can get R square is equal to AB. So AB is what? AB we have x minus a square plus BB. BB is the same as y minus b, so we have y minus b square. So now this particular one is called equation of a cycle. So we call equation of a cycle. So we can be asked to form the equation of a cycle. Then what we will do is to make sure we use this particular formula to form the equation. For example, we are going to find the equation of a cycle whose center is and the radius it has the coordinate of the center is 2 and minus 3 and the radius is 2. So if we are asked to find the equation of this circle, we take the solution in this way. The equation of the cycle is given by x minus a squared plus y minus b square is equal to r square. So remember that this equation of the cycle is derived from the coordinates of the center A and B. So now the coordinates of this center here is 2 and minus 3. So 2 is for A and then minus 3 is for B. So fixing this, we will have x minus 2 square plus y minus 3 square will be equal to r is 2 square. So that we now have, by this you have x minus 2 square plus y plus 3 square will be equal to 2 square. So expanding this, we have x square minus 4x plus 4. This is by binomial expansion. So expand it by binomial expansion, then you get this. Make sure you watch our lectures on binomial expansion so that you know how to expand, because a lot of expansions are there in circle. When we enter circle, we talk about a lot of expansion. Now, plus y square plus 6y plus 9 is equal to 4. So this is 4. Now, if we do that, we now have x squared minus 4x plus y squared plus 6y plus 13 equal to 4. It is 13 because of 9 and 4. So if I bring this to this way, I'll have x squared minus 4x plus y squared plus 6y plus 13 minus 4 is equal to 0. So what that means is that x squared minus 4x plus y squared plus 6y plus 9 will be equal to 0. So this is the required equation. As I said, we should find the equation of a circle whose center has coordinate 2 and minus 3 and the radius is 2. So this is the equation of the circle. Now we'll also look at other examples. We are taking another example. Find the equation of the circle whose center is 5 minus 2, that is the coordinates of the center, and passes through the points minus 3 and 2. Now, we will take the solution. If you look at this question, you see that in this particular type, you are not given the radius of the circle, like the one we just finished. They give us the radius 2 and the coordinates. Now, what we will do is to first of all find the radius. And how do we find the radius? We know that the coordinate of the center, look at, we have a circle, and they say the coordinate of the center is 5 and minus 4. So this is the center. And it passes through a point, maybe like, let's call it point P, minus 3 and 2. So we should know that this is R. So what we do is to find the distance between here and here. So what we will do, we will first of all find R, and we know that the distance between any 2 points is given by x2 minus f squared plus y2 minus y1 squared inside square root. The square root of this will get the distance. So what we will do is we will now substitute the value of x2, x1, y2, y1. Know that this particular point is point 1 and this particular point is point 2. So x2 here is minus 3. So you have minus 3 minus 5 square plus y2 which is 2 minus 4. So this is minus 4. Alright, so we have square. Now that will give us square root of, this is minus 8 square plus, of course, this plus this will give us 6. That is minus times minus 4 give us plus 6. So we have 6 squared. And if we get that, it means R will be equal to, you see, minus 8 squared will give us 64. Then 6 squared will give us 36. So what do we have? We have 100. Of course, R is 10. So we have got the radius now. We have got this radius to be 10. So now we can form the equation of the cycle. We know that to get the equation of the cycle, that x minus a squared plus y minus b squared will be equal to r squared. But let us not forget that these a and b, they are coordinates of the center. So we will now go to the question and look at the question. Whose center is this? So this is the center. And now we'll bring that coordinate of the center and fix it here to find the equation. Now we'll now do it in this way. X minus a, which is 5, in this case, squared, plus y minus b, and b here is minus 4. So we'll have minus 4 will give us plus 4 here. Because of minus times the minus with that coordinate. We have plus 4 squared will be equal to r squared. And what is r? 10 squared. That was the reason why we started by finding r. So we can substitute r in this place. Now, if we expand this, we will have x squared minus 10x plus 25. You see, the expansion of this by binomial expansion is very easy. What it means is that x minus 5, x minus 5. You know, x squared means like this. So x times x will give you x squared. X times this will give you minus 5x. That is x times 5. X times minus 5. So minus 5 times x will give you minus 5x. Minus 5 times minus 5 will give you plus 25. So you can see that we have x squared minus 5x minus 5x give us minus 10x plus 25. Now this particular one here is what I'm expanding here. But I'm using binomial expansion here. Binomial expansion will make it very fast way to get. Now you can watch the lectures on binomial expansion so that even though it is raised to power 20, power 40, you don't have problem, you can expand it easily. Now plus we enter this one. This one will be y squared plus 8y plus 16. How do I know? If I have y here, I have 4 here, I have power 2. So we just say 2 times y times 4 will give me 8y. Then I say 4 squared give me 16. What binomial expansion can get that? So here is what? 100, 10 squared. So I can now rearrange this equation to write it as x squared minus 10x plus y squared plus 8y. Then I have 41 plus 41 minus 100 is equal to 0. You see, I'm transferring this 100 to this side, so it will turn to minus. What it means is that x squared minus 10x plus y squared plus 8y minus 59 is equal to 0. This becomes the equation of the cycle that I was asked to find. And this equation of the cycle is the equation of the cycle whose center has coordinates 5 and minus 4. And the radius is 10. So you get this equation of the cycle. That's how it is done. Now we look at this example. Another one. Find the equation of a circle whose diameter has n points and the coordinate of the n points of the diameter is 5 and 4 and 7 and 4. Now let's take the solution so that you also see this pattern how it is solved. Now what they mean is that there is a circle, it's a circle, this nature, and then we have the diameter. You know, the diameter will always be a line that divides this circle into two. So they say that this one has coordinate 5 and 4, this particular point, and that at this point it has 7 and 4. So they say we should find the equation of the circle. Now, we know that before we find the equation of the circle, we must have the coordinate of the center, and then we have the radius. But here, it is not given. But we can get the coordinate of the center by knowing that this diameter, if we divide it into 2, then the center here will have a coordinate, and this one side becomes the radius, and this side is the radius. You know that 2 radius makes a diameter. So to get the coordinate of the center, we will use midpoints of a line. A formula for getting the midpoint of a line. Now, let's call this point A and call this point B. Then, midpoint of AB is given by the coordinate of midpoint. The coordinate of midpoint of AB is given by x2 plus x1 divided by 2 and y2 plus y1 divided by 2. So here we have x2. x2 is this, and we have x1. So we will have 7 plus 5 divided by 2, and then the coordinate of this one, which is 4 plus 4 divided by 2. Now, so we have 12 by 7 plus 5. 12 divided by 2, then we have 8 divided by 2. So this one will be 6, and this one 8 divided by 2 will give us 4. So the coordinate of the center becomes 6 and 4. 6 and 4. Now, this one, we are going to now find the radius. The radius, you know that since we have got the coordinate 6 and 4, which is of the center, that from the center to this point A is the radius, from this center to here. So to get the radius, we use distance between 2 points, which is given by r is equal to x2 minus x1 squared plus y2 minus y1 squared. Now here we know that x2 is 6 minus 5 squared plus y2 is 4 minus 4 squared. Of course, we have square root of 1 because 6 minus 5 is 1. Even though we say 5 minus 6, it will give us minus 1. When you square it, you still have 1. So this will give us 1. So r is equal to 1. Now that we have got r, we also have the coordinates. So we can now form the equation of the circle, because with that we will form it. So the equation of the circle is given by x minus a squared plus y minus b squared, which is equal to r squared. And so here we will have x minus a. You know, a is the coordinate of the center. The coordinate of the center. So we say 6 squared plus y minus b, that is 4 squared, which is equal to r squared, and r is 1 squared. So if we expand this, we have x squared minus 12x plus 36 plus y squared minus 8y plus 16 will equal to 1. Now we can rearrange it to write x squared minus 12x plus y squared minus 8y, then we bring this 36 and this one we have 47. No, 52, that is 36 plus 16, we have 2, 52. We have plus 52 minus 1 is equal to 0, which means x squared minus 12x plus y squared minus 8y plus 51 is equal to 0 is the required equation that we were asked to find. So that is how we can find this equation if we are asked to find it given this type of question. We are looking at the general form of equation of a cycle. Now, from the equation of the cycle that we have derived, we see that it is of this form: x minus a squared plus y minus b squared is equal to r squared. This is the equation of the cycle with coordinate of the center a and b. Then, if we expand, we will have x squared minus 2ax plus a squared plus y squared minus 2by plus b squared will be equal to r squared. Now you can write it as x squared minus 2ax plus y squared minus 2by plus a squared plus b squared minus r squared equal 0. I'm bringing r squared this way. So I have x squared minus 2ax plus y squared minus 2bx. So I'm bringing this. Where a squared, b squared, and r squared, they are constants, they are numbers. Now, if we let C is equal a squared plus b squared minus r squared, then we will have this equation in the form x squared minus 2ax plus y squared minus 2by plus c is equal to 0. Now, if a is equal minus g, which is the coordinate of the center, and then we also have that b is equal minus f. So what we do is, in this place, we are going to replace a with minus g, and then we have plus 2gx plus y squared plus 2fy plus c equals 0. Now, this one is called the general form of equation of a cycle, where the coordinates of the center is at g and f. So this is the general form of equation of the cycle. Now, we want to take properties of the cycle. Properties of the cycle. Properties of a cycle. Now, let's write this general form again. X squared plus y squared plus 2gx plus 2fy plus c. Now, if we write this in, what we find out, number one, is that in this equation, that the highest power is 2. That is, it is of degree 2. The highest power that the equation has is 2. And we also find out another thing, that there is no term in xy. There's no term in this equation that we have xy as the product of x and y. We also find out that the coefficients of x squared and y squared are equal. So in any equation of the cycle, the coefficients of x squared and y squared must be equal. In this one we have 1 here. There's also 1 in this place. So they must always be equal. So we have derived this property. The property will help us to know the equation of the cycle. Now, there is one important thing that we want to talk here. If we are given equation of the cycle, we can bring out the center, the coordinate of the center and the radius if we are given using completing the square method. So that is next example that we want to take now. Let's see how we can, if given equation of the cycle, bring out the coordinate of the center and also the radius. We are looking at another example. Find the coordinates of the center and the radius of the cycle whose equation is 5x squared plus 5y squared minus 3x plus 7y minus 1 is equal to 0. Now, I have told you that if we are given equation of the cycle, that we can bring out the coordinate of the center and the radius using completing the square method. Now, completing the square method is in quadratic equation. If you have not watched our lectures on quadratic equation, very, very interesting. You have to get a copy of that and watch it. Now, from this question, there is one thing we find out. We see that the coefficients of x squared and y squared are equal, which is one of the properties of the cycle, of the equation of the cycle. Now, and it is of degree 2, and there is no term in xy. All equations of the cycle must obey these properties. So we have 5x squared plus 5y squared minus 3x plus 7y minus 1 is equal to 0. Now, if you know completing the square very well, or if you don't know, you can follow, you see that the first thing we do is to take this constant across. So we have 5x squared plus 5y squared minus 3x plus 7y will be equal to 1. We are taking this constant across. And the next thing that we are going to do is to divide. I'm going to divide both sides by the coefficients of x squared and y squared. If you do that, we will have x squared plus y squared. You know, we are dividing both sides by the coefficient. And the coefficients of x squared and y squared are 5. So if I write 5 here, divide by 5, they will cancel out. So that's why I'm writing x squared and y squared minus 3 all over 5 x plus 7 all over 5 will be equal to 1 all over 5. So I'm dividing both sides. Then after that, the next thing I will do is to add to both sides half square the coefficients of x and y. If we are adding x and y, if it is completing the square, it's only x because we have only one variable, so this is 2 variables. And if we do that from here, we will have x squared plus y squared minus 3x all over 5 plus half of this. Of course, half of this is 3 all over 10. Then square. You know how? Because half, if I say half, then I must put 2. That's why I said to watch the package for quadratic equation to find out this very well in details. So half of anything is times 2. If I say half of 10 is 10 divided by 2, which is 5. Now what about half of 4? 3 over 4. Half of 3 over 4 will be 3 over 8. Because I will just put the 2 here. What I'm doing is that I'm dividing it by half. So this 3 over 4 is the same thing as saying 3 over 4 times 1 over 2. So we'll have 3 over 8. So that is how we add the half. The half of this is 3 over 10. Now, plus 7y, 7 all over 5y, plus half of it, which is 7 all over 10 square, will be equal to 1 all over 5. Then I will add this half, because I'm adding to both sides. We'll add this half again, that is plus 3 all over 10 square, plus 7 all over 10 square. I'm adding it to both sides. Now if I do that, next thing I will do is to write x minus 3 all over 10 square. In completing the square, this is where we complete the square. So I'm picking this and this, because this one is inside here, so you don't need to repeat this one again, but here. So I'm bringing this, and if I have x squared and minus 3 all over 10 square, I can write x, I can bring x and minus 3 all over 10 in bracket and square it, which means the same. So that is what I'm doing here. Plus, then I will have y plus 7 all over 10 square. So this and this again come. Why I will not write this one again? Because here is already inside here, which is the same as 1 all over 5 plus 9 all over 100, that is minus 3 square and 10 square, plus 49 all over 100. And the next thing I'm going to do is to take the LCM on this side, which is 100. And 100 divided by 5. 100 divided by 5 will give me 20. Okay, 20 plus 9 plus 49. So I have 49 plus 9. That will give me 58. 58 plus 20 will give me 78. Alright. So everything here is 78 divided by 100. Now that means y plus 7 all over 10 square is equal to this, which is also equal to this. Now, for me to remove this, I have to square root the other side. So what I will do is x minus 3 over 10 plus y plus 7 all over 10 will be equal to the square root of 78 all over 100, which is the same thing as x minus 3 all over 10 plus y plus 7 all over 10, which is the same as root 78 all over 10. Because this square will cover up and down, but this is a perfect square. So we have this. So we now see in this equation now, this is the coordinate of the center. The coordinate of the center falls here. Now that we have x minus 3 all over 10, it means the coordinate of the center is the coordinate of the center. Therefore, the coordinate of the center is 3 all over 10 and then minus 7 all over 10. These are the coordinates. You know how? Because x minus 3 all over 10, if I equate here to 0 and make x subject of the formula, then I will have 3 over 10. Then this side will be minus 3 over 10. We have that. While r, the radius, is 78 all over 10. Now we have got the coordinates and we have got the radius. So in the question we will ask to find the coordinates of the center and the radius of the cycle whose equation is as given. So this is the coordinate and this is the radius of the cycle. Now we are looking at another example where we can also use the general form of equation of the cycle. The general form of equation of the cycle can help us to solve problems of this nature. For instance, if we are asked to find the equation of the cycle which passes through the points, you see, the points are up to 3 now. So we will use this equation, the general form of equation of the cycle, to derive the required equation of the cycle. Now, let these points be point A. Let the point be A, the coordinate 1 and 1. Then we have point B, coordinate 2 and minus 1. And point C, we have the coordinate 3 and 2. Now, recall that the general form of equation of the cycle is given by x squared plus y squared plus 2 gx plus 2 fy plus c is equal to 0. So what we will do now is we will pick these points one after the other and substitute here and we form equation. So if we do that for point A is this 1 and 1. We'll substitute in the place of x and y. Of course, you know that this one is for x coordinate and this one is for y. So for point A, we'll have 1 squared, as we are putting it here, plus 1 squared plus 2g. You know, if we put 1 here, we have 2g plus 2f. We put 1 here, we have 2f plus c equal 0. That will simplify to 1 plus 1 plus 2g plus 2f plus c equals 0, which means 2g plus 2f plus c will equal to minus 2. Call this equation 1. We can also look for point B. For point B, which is this particular point, when we substitute it in the general form of equation of the cycle, we will have, this coordinate is 2, so we have 2 squared plus this minus 1 squared plus 2g, then we put 2, which is the coordinate of x, plus 2f, then we put minus 1, which is the coordinate of y, in the place of y, plus c is equal to 0. If we do that, we have 4 plus 1 plus 4g, that is 2 times 2, plus 4g plus, minus 2f plus c is equal to 0. So when we add up this one, we'll have 4g minus 2f plus c is equal to minus 5. Call this one equation 2. So you have equation 1, for this one you have equation 2. We can also put these coordinates, and when we put the coordinates in the general form of equation of the cycle, for this coordinate you have 3 square, that is putting it here, 3 in the place of x. We have 3 square plus these 2 square plus 2 g 3 in the place of x plus 2f, then we put 2 in the place of y, so it has y coordinate is 2, plus c is equal to 0. Now if we do that, we have 9 here, plus here we have 4, then here we have 6g plus 4f plus c is equal to 0. That means here we have 13. So we write 6g plus 4f plus c will equal to minus 13. See 13, and transferring this to the other side, so I have this, which is equation 3. So we have 3 equations now: equation 1, equation 2, and equation 3. Now we are going to solve it simultaneously. Solving simultaneously from 1 and 2, that is from equation 1 and 2. Then we'll have something like this. We are picking 1 and 2 first. So we'll have 2g plus 2f plus c equal minus 2. And we also have for equation 2 that 4g minus 2f plus c is equal to minus 5. Now, what we are going to do now is to eliminate c. So for us to eliminate one thing here, we must minus. We minus equation 1 and 2. We subtract 1 and 2, equation 1 and 2. So we subtract. You see, we have 2 minus, or even if we say 4 minus 4g minus 2g will give us 2g. Now minus 2g minus 2g will give us 2f will give us minus 4f. Then this thing will be 0. C minus c will be 0. So we'll have here minus 5 minus 2. So we'll have minus 3. Because minus 5 minus will make this one to be plus. So we have minus 3. For this one, equation 4. And then if we do that, we can also pick from 1 and 3. From 1 and 3, we will have that 1 is 2g plus 2f plus c is equal minus 2. And then we also have for 3 is 3. We have 6g plus 4f plus c is equal minus 13. Now we also want to remove c. And for us to remove c, what do we have? 6 minus 2 will give 6g minus 2g will give us 4g plus 4f minus 2f will give us 2f. Then this will become 0, which is now this is minus 13. Minus 13 minus 2. So what do we have here? Minus 13 minus 2. We'll make this one plus. So we have minus 12. We have minus 11. Sorry. Minus 13 plus 2 give us minus 11. Now call this one equation 5. That is equation 5. So we have 5 equations now. But we see that equation 4 and equation 5, they have two variables. So we can solve equation 2 and 5 simultaneously, equation 4 and 5 simultaneously, by saying equation from 4 and 5, we will write 2g minus 4f is equal minus 3, and we also have 4g plus 2f is equal minus 11. Now, solving simultaneously, you see here we have 2, we have 4 here. Before we can eliminate, the coefficients must be equal. That was why here we have C, the coefficients are equal. So before we can eliminate. But here, before we eliminate, we must make the coefficients equal. And so what we do is we are going to multiply equation 5. This is equation 5. This is 4. So multiply equation 5 by 2. If we do that, we will have 2g minus 4f is equal to minus 3. That is equation 4. And when we multiply this by 2, we have 8g plus 4f will be equal to minus 22. Yes, minus 22. So we now add this equation, add equation 4 and 6. You know that this is new equation, so we can call it equation 6. That 8g plus 4f is equal minus 22. It's a new equation. So when we add together, 4f minus 4f plus 4f will go. So when we add, we will have 10g will be equal to, if you see, when we add this one, we have minus 25. That is minus 3, minus 22, minus 25. So that g will be equal to minus 25 all over 10, which is the same as minus 5 all over 2. Because 5 will cancel here 5 times, 5 will cancel here 3 times. So g is equal to 5 minus 5 over 2. Alright, we can now put g is equal to minus 5 all over 2 in equation, we can put it in equation 4 because we have two variables here. So if we put that, equation 4 says that 2g minus 4f is equal to minus 3. So if we put g is equal to this, then we'll have 2 minus 5 all over 2 in the place of g minus 4f will be equal to minus 3. So now, if we times this, we will have minus 10 all over 2 minus 4f will be equal to minus 10. But this will give us minus 5 because minus 10 divided by 2 is minus 5. Minus 4f will be equal to minus 10. So minus 4f will be equal to minus 3 plus 5. And then minus 3 plus 5 will give us minus 4f will be equal to 2. So f is what? F is 2 all over 4 minus 2 all over 4. That is f, which is the same as minus 1 all over 2. So f is minus 1 all over 2 and g is minus 5 all over 2. Alright, but we can now get c because we need to get g, we need to get f, we need to get c because we have 3 variables. And so when we put these 2, we are going to put g is equal to minus 5 all over 2 and f is equal to minus 1 all over 2 in equation 1. We go back to equation 1. Equation 1 says 2g plus 2f plus c is equal minus 2. So if we put that, we will now have 2 minus 5 all over 2, that is in the place of G, plus 2 minus 1 all over 2, that is in the place of F, plus C will be equal to minus 2. So this is minus 10 all over 2 minus 2 all over 2 is it 2 times minus 1 because minus 2 all over 2 plus C is equal minus 2. So this one is what? Minus 5. And this one is what? Minus 1. Yes. Minus 10 all over 2 gives us minus 5. Minus 2 all over 2 gives us minus 1. Plus C is equal what? Minus 2. So here, minus 5 minus 1 is minus 6. So we can write that C is equal to minus 2. Then taking this minus 6 to this side, we come to plus 6. Which means that C is equal to what? 4. Now if we put that, all these values in the equation of the cycle, we can now bring out the equation. Look at the equation of the cycle in general form is x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So we now fix the values. We have x squared plus y squared plus 2g. G is what? Minus 5 all over 2 x plus 2f, f is minus 1 all over 2 plus c, which is 4, is equal to 0. So we will have x squared plus y squared. Now look at this. 2 times minus 5 is minus 10 divided by 2 minus 5. So we have minus 5x. Now this one we have, remember we have y. We have 2fy, so there's y here plus 4. So this time this is minus 1. It's minus 2. Minus 2 divided by 2 give us minus 1. So we have minus y because of this y plus 4 is equal to 0. Now this becomes the required equation of the cycle. When we are given 3 points, so we can use simultaneous equation by substituting these points. It's very easy to do. It's not difficult. Another thing is that another pattern is there. Another pattern is that we can pick any 2 points and find the coordinates, the midpoint of these 2 points. After getting the midpoint, we can now find the gradients of the points. After getting the gradient, we now find the perpendicular distance of this point. After getting that, we form the equation of the perpendicular line. Then you pick another 2 points, get the midpoint, and also find the gradients of the points. After finding the gradient, you find the perpendicular, the equation of the perpendicular line, and then you solve these 2 equations simultaneously. You see arrive at this particular point. You can use that. Or if you don't want to use that, after forming these 3 equations, we have 3 equations: equation 1, equation 2, equation 3. You can use determinant method. Maybe you want to use Cramer's rule. You still get the value of G, value of F, and the value of C. These things are simple to do. So study it very well, and then you know the pattern. Now we are looking at equation of the tangent at a particular point that has coordinate x, y. Now, we recall that the equation of the cycle in the general form, that is the general form of the equation of the cycle, is given by x squared plus y squared plus 2gx plus 2fy plus c equals 0. Now, if we differentiate this equation using implicit differentiation, we will have 2x plus 2y dy all over the x. I believe you have watched our lectures on elementary calculus. You know implicit differentiation. So we have plus 2g when you differentiate here, plus 2f y all over the x will be equal to 0 because c is a constant, so we have 0. If we do that, we can now write in this form that 2y dy all over the x plus 2f dy all over the x is equal, I'm bringing 10 containing dy dx to one place, will be equal to minus 2x minus 2g. Minus 2x, I'm transferring this 10 now to the other side. Now I can now factor out dy dx. Dy dx, then we'll have 2y plus 2f. Okay, and it will be equal to minus 2x plus 2g. If I write it like this, it is set to like this. So dy dx, dy all over the x will be equal to minus 2x plus 2g all over 2y plus 2f. Of course, if you simplify to dy dx is equal, when 2 cancel this here, minus x plus g all over y plus f. Now, at the point x1, y1, we will now have that the y all over x is equal to minus x1 plus g all over y1 plus f. But we should not forget that the y dx also means the slope or gradient. The y dx means gradient. Also, when we differentiate the function, they are differentiating to get the slope. And so we can now see that the gradient of a line, is given by y minus y1 all over x minus x1. So it will be equal to, this is the gradient of a line with a gradient and 1 point form. So it will be equal to minus x1 plus g all over y1 plus f. Now, if we cross multiply this thing and make a suitable substitution, we can have the equation of the tangent of the cycle. And to simplify the whole thing, the equation of tangent of the cycle is given by x times x1 plus y times y1 plus g bracket x plus x1 plus f bracket y plus y1 is equal to 0. So if we have this, we can get the equation of the tangent. Sorry, plus c. We put c, so we get the complete equation of the tangent. Suppose we are asked to find the equation of the tangent to the cycle. The cycle is given by this equation: x squared plus y squared plus 2x minus 3y minus 13 equals 0 at this particular point. This point that has coordinates 1 and minus 2. So we should find the equation of the tangent. Now let's set the solution, how we can find this equation. The first thing we do is that we have to know that the equation of the tangent to the cycle is given by x times x1 plus y times y1 plus g bracket x plus x1 plus f bracket y plus y1 plus c is equal to 0. and that we have this equation, which is x squared plus y squared plus 2x minus 3y minus 13 is equal to 0. So we have to find g and f, because we are given x1, y1. We have already given this is x1 and this is y1. So for us to find this g and f, we know that g and f is the center from what we have derived before now. So what we will do is to use completing the square. Half of the coefficients of x and y will give us g and f. So that is x squared plus y squared plus 2x, half of this. So what is half? Half of this is plus 1 squared. No, plus 1 half. We will not square, only the half. Just half of the coefficients will become g. So half of this for g will be equal to 1 minus 3y. Half of minus 3 is what? For f is minus 3 all over 2. Because so everything half is divided by 2. So half of this is minus 3 all over 2. Now what about c? C is minus 13. See here. If we substitute these values in this equation, it becomes the equation of the tangent. Now let's substitute it and see. So we have x times 1, because x1 is 1, plus y times y1. y1 is minus 2. Then plus g is what? G is 1. Bracket x plus x1 is 1, plus f, of course f is minus 3 all over 2. Now bracket, we have another bracket here, bracket y plus y1, of course y1 is minus 2, so I can get minus 2 here, plus c, and c is minus 13 is equal to 0. So we can form the equation here. Now here we have x minus 2y. Then here we have plus x plus 1, because this is 1. 1 times this will give us this. Minus 3y plus 6, because minus 3 times minus will give us plus 6 all over 2 minus 13 is equal to 0. Alright, so now in this one we have here over 2, so we have to take SCM of all this. If we take the SCM is 2. So what we have here is that 2 divided by 1, all this is over 1. So we have 2x minus 4y plus 2x plus 2 minus 3y, because this, if it goes here, it will be 1. So you have minus 3y plus 6 minus 26 is equal to 0. Yeah, like that. And so if I cross multiply, I will have 2x minus 4y plus 2x plus 2 minus 3y plus 6 minus 26 is equal to 0. Now, the next thing I will do is to collect like terms, because this and this, they are the same. So write 4x, then minus 4y minus 7y, they are the same. Minus 3y, they are the same. So I have minus 7y. I have a constant here. I have a constant. So 2 plus 6 is 8. Now 8 minus 26 will give me minus 18. It's equal to 0. So this is the equation of the tangents. 4x minus 7y minus 18 is equal to 0. This becomes the equation of the tangent. And you can see the tangent is a line that touches the tangent of the cycle is a line, straight line that touches a particular point on the cycle. And if it is a straight line, it means it is of degree 1. And that is why you see the equation is of degree 1. It is a straight line, it's a line. So that's how you can use tangent, equation of tangent, to get the tangent to a cycle. Now, the next one we are going to look at is length of tangent of a cycle from an external point. Now, this is what we are talking about. If we have a cycle like this, we know that this is the center of this cycle. Now, a tangent, like I've said, is a straight line that touches a cycle at a point. So, and then this is the radius of the cycle, or the radius of the cycle, which we know. So, our interest here is to know the length of this tangent, or the length. So, if this is a point, call this point Q, and it has coordinates x1, y1. And if we join this to this point, we see that we have a right angle triangle. So this is R. Now this is the tangent that we are talking about. Let us represent it by T for tangent. And this particular line here, we know that it is the hypotenuse. So let's represent it by H, representing hypotenuse. Now, but we also know that by Pythagoras theorem, R squared plus T squared will be equal to H squared. Yes. By Pythagoras theorem, we will get this. And that T squared, for us to get T squared, it will be equal to H squared minus R squared. Like when we transfer this to this side. But only H squared will be the same. You know, if I have coordinate here, this is the center. So let me get coordinate, say A and B at the center. Then that means only H squared, that is this side, only H, this H squared, will give me X minus A squared plus Y, that is X1 minus A plus Y1 minus B squared. Yes. So that if I use this now, I can get the tangent. See my tangent here. Now, for us to understand this thing properly, we are going to take one example that will help us know how we can derive tangents, how we can derive the length of the tangent. Now, let's take this example so that we can understand how we can use this formula now to find the tangent of the cycle. If you are given to find the length of the tangent of the cycle, and we are given this cycle at this point. Now, the first thing we will do, we know that what we need here, we need the coordinates of the center. We need R. Because at this particular point, before we get this height here, we will need the coordinates of the center. And then, before we get the tangent, this is R. So these two things now will make us have the tangent. So, but those two things are here, inside here, which we have solved before now. So we will find the coordinate of the center and also find R. By the time we get these things, we will now get the length of the tangent. So we have x squared plus y squared plus 5x plus 4y minus 20 equals 0. By completing this square, we will have x squared plus y squared plus, we will take the constant across. So we have 20. And the next one is to divide both sides by the coefficient of x squared. And the coefficient of x squared is 1. So it will still remain the same. Now the next thing we are going to do is to put half of this and we square it, half of the coefficients of x and y. So if we do that, we will have x squared plus y squared plus 5x plus 5 all over 2 squared plus 4y plus 2. You see, what we have to is that 4 divided by 2 is 2. So we can now square will be equal to 20 plus 20 plus 5 all over 2 square plus 2 square. So if we do that, we can now write this as x plus 5 all over 2 square, taking this one, plus y plus 2 square, that is this one and this one, which is equal to 20 plus 25 all over 4 plus 4. That is because 5 square will give us 25, and then 4 square will give us, 2 square will give us 4. Now we can then take the LCM of this place. The LCM here is 4. Now 4 divided here is 4, because this is over 1. And then 4 times 20 will give us 80. 80 plus 25 plus this side is 4 plus 16. Alright? So x plus 5 all over 2 square plus y plus 2 all over 2 will be equal to this. Now this is the same thing. This is the same thing as x plus 5 all over 2 plus y plus 2, which will be equal to, is this one, 80 plus 25 will give us 105 plus 16, 121, 121 all over 4. We are removing this square, so we have to square root this side. That means x plus 5 all over 2 plus y plus 2 will be equal to, if we square root this, we have 11 all over 2, because this is a perfect square. 121 is a perfect square. It gives us 11. So when we square root this, we have 2. So now you can see that the coordinates of the center, we have minus 5 all over 2 and then minus 2. What are the coordinates? While r is equal to 11 all over 2. Now, if r is 11 all over 2, it means r square is this. So r is this, because we will need r square. So r square is equal to square root of 1, 2, 1 all over 4. That is r square. No, r square is 11. 1 to 1 all over 4. 1 to 1 all over 4. That is r square. It's equal to 1 to 1 all over 4. Alright. So now we can now look at the tangent. Now see how this thing looks like. I have a circle. So this is the tangent now. and the tangent goes to the point of the question. This is 2 and 3. So, and I have the center here. So this is the radius. Okay, so if I join this to here, I have the coordinate of the center. Coordinate here, -5 all over 2 and -2 at the center. Now this is my t, this is h. So see what it asked me to find. So, but I know that t squared will be equal to h squared minus r squared. That was what we have in the formula that we derived by Pythagoras. So if that happens, it means, and then we know that h squared is the same as x minus a squared plus y minus b squared. So let's find h squared. H squared will give us this is x1, sorry, y1. So x1, y1, x1, this one is x1. Then a is this one. So x1, which is 2, minus, it will give us plus 5 all over 2 squared plus, we go to this way, we have 3 in this coordinate. 3 minus, of course, this minus will be plus because we have -2 here, square. So if we have that, we now that h squared is equal to, if we take LCM of this, we have 9 all over 2. That is, LCM is 2 times is 4, 4 plus is 9 all over 2. 9 over 2, okay, square. Now this is 5 square. So h squared is the same as 81 all over 4 plus 25. See, that is h squared. So taking the LCM of this, the LCM of this, we will have 81 plus 100 all over 4. Okay, you know how? Because LCM of this is 4. So we have 4 going here 1 times the 81. 4 going this way times the 5 will give us 100. So h squared is equal to 100 plus 81 will give us 181 all over 4. Alright, so that is a squared. Now, how do we get t? Because t is the tangent that we want. So how do we get t squared? We know that t squared is equal to a squared minus r squared. So t squared will be equal to a squared, which is this 181 all over 4 minus r squared. And r squared is what? R squared is 121 all over 4. If I take the LCM here, t squared will be equal to 181 minus 121. 181 minus 121 give me 60. Give me 60. So I have 60 all over 4. But t, only t now will become t is square root of 60 all over 4. Now I can also write it in this way. This is square root of 60 all over 4. I can also write it in this way. Square root of 60 divided by 2. Yes. But even this square root of 60, I can further simplify it to write square root of 50 and make one perfect square. And make the other one, okay. So we have square root of 4 times square root of 15 all over 2. Now this will give me 2 root 15 all over 2. Of course, these 2 can cancel these 2. So t is equal to what? Root 15. Yes. So that is the length of that tangent, root 15. You can see how we can derive it. So getting the length of these tangents, you have to find the coordinates of the center, and then you find the radius. Then you fix it and you get the length.